Good afternoon and welcome to this afternoon session on probability theory. Just before this session, you have already had one session on economics. This is our today's second session also on economics, and this topic of probability theory is covered in your course MEC 003 and also EEC 5. And this topic is one of the basic topics which will help you in understanding many other papers that are also covered in the MEC course. For example, MEC 009, in which you will be taking a optional paper on research methods, as also a basic econometric course, in which also these fundamentals that we will discuss today will be extremely helpful. I shall be discussing this topic today in two formats. I am beginning with the introduction to the course, with the introduction to the topic, and then I will be requesting our guest faculty today, Dr. Anup Chatterjee, who is with us today, and he will be taking you with some of the basic aspects with which you will be benefited by knowing. You are all aware that you are free to intervene to ask any question, and you are also free to ask the question both in English as well as in Hindi. There need be no hesitation to ask the question in Hindi, and at any time you want, and you are welcome to seek any clarification that you require. So I will proceed now to introduce some of the basic terminologies that we use under probability theory, and I will give you a theoretical or a descriptive explanation, and then we will try to build on that to go on to the next stage of our presentation, which is on results. All of you know, and you can understand by the very basic term of probability, that here we are trying to answer something about an uncertain situation but in certain terms, telling something in definitive terms about an indefinite term. So you begin with an understanding of the two basic concepts: what is a definitive event and what is an indefinitive event. A definitive event or an experiment is one in which the result is known and it will be uniform even if it is repeated in number of situations under varying circumstances. You are aware of the classic example of switching a coin or a stone to the air. It will always reach the earth wherever you repeat the experiment. That means it is a definitive event, definitive experiment with a known result. In probability theory, we shall not be dealing with such kind of experiments. We shall be dealing with such kind of experiments which are having non-deterministic, that is non-definitive situations where the outcomes are several but are known. So we will then be interested in knowing if a particular event has to happen, then what is the probability, and can we estimate it, and what are its requirements, and so on and so forth. That means we are here dealing with random. Non-deterministic is same as random, a random experiment and a random event. So when we talk of event, I must tell you that there are 5 different connotations which go with that, and I shall be explaining them to you in simple terms. First is a mutually exclusive this thing. So under a mutually exclusive this thing, what we mean by mutually exclusive is 2 or more events cannot happen simultaneously. Only one at a time will happen. That's what we mean by mutually exclusive events. The second term is mutually exhaustive event. By a mutually exhaustive event, what we mean is out of all the possibilities, at least one of them will definitely occur. That's what we mean by saying mutually exhaustive event. The third is equally likely. An equally likely event is one. By that what we mean is, and the set of all events is called as the sample space. So from the sample space, any one event is as possible to occur as the other event. That is, one event does not get undue preference over the other. There is no such thing, and each and every event is likely to happen in the course of the experiment. The third concept of events is independent. There again we mean occurrence of one event is not affected or influenced by the occurrence of the other event. The fifth one is a conditional event. There can be situations where a particular event will happen if and only if some other thing will happen. For example, if you have to have rain, there has to be cloud. Without the clouds you cannot have the rain. In such a situation, we talk of conditional probability. So as we build this theory using some formal terminologies, formal conceptual this thing, we should be having at the back of our mind what we mean by an experiment, what we mean by the random character of an experiment, and what are the various types of events that can occur. So with this basic thing given, I now request our guest faculty today to please initiate this session and take us through some of the basic results, and these results shall be in the form of total probability theorem, compound probability theorem, and one or two other things, with an idea of helping you to understand as you go through the session what are the things that are involved, what are the basic results that are governed in this theory. And with this basic introduction, I now request Professor Dr. Chatterjee to please take on and say something to help us to further our knowledge in this area.
Thank you, Dr. Prakash, and a very good afternoon, you all friends. Probability is a very important concept. After all, it deals with uncertainty. And all of us know that we live in an uncertain world. So, in order to handle the uncertainty involved in certain situations, we have to have a thorough grounding in probability. For example, say we are trying to forecast about the GDP growth rate. Now we build up an economic model, we try and estimate its parameters, and then we try and forecast. Now, it's really not possible for us to sort of, systematically arrange all the informations properly and then try and forecast. So what we do is we just have some limited information at our disposal, and from that limited information we try and conclude about something that is much bigger. Obviously, in such kind of a situation, we are concerned with some element of uncertainty. So unless we have sort of a thorough understanding of this element of uncertainty, we probably will not be able to do justice. So it is in this context we have to have a thorough grounding, a thorough knowledge about probability theory. So, be it economics, be it business, be it any branch of social science, one cannot go further without the knowledge of probability. Now, the first thing that we have to consider in probability is what really is meant by the probability of any event, be it an elementary event, be it a compound event. Probability of any element is in fact assigning numerical values to all possible outcomes of a random experiment. Now, sometimes when we refer to all possible outcomes, we also use the term elementary events. But it need not be an elementary event, it can be a compound event also. So, in the case of a compound event also, from our knowledge of assigning probabilities to elementary events, we can assign probability to a compound event also. Now, when we assign such kind of a numerical value, we have to take care of two things. The first is, to each event, we can assign only one such kind of a numerical value. We cannot have more than one numerical value to a particular event simultaneously. Now, such kind of a relationship where there is one-to-one correspondence is known as a functional relationship. So, when we write that probability of, say, a particular event A is PA, there this P stands for function. And then we say that probability of a particular event is PA, and we assign a numerical value. The second requirement is, while assigning such kind of a numerical value as the probability of an event, we have to have certain axioms. certain conditions. These are called the axioms of probability. And what are those axioms? In simple terms, there are three axioms. The first is that probability of any event, say, is greater than or equal to 0 and less than or equal to 1. What does it mean? It means that probability is a positive number not exceeding 1. The second axiom is that probability of a certain event is always equal to 1. Now, Dr. Prakash has already introduced the concept of a sample space. Now, when we consider the entire sample space, then the probability of occurrence of any of the outcomes of this sample space that arises out of a random experiment is certain. So we write probability S is equal to 1. The third is that if we have, for example, two mutually exclusive events, then the probability of either A or probability of B is given by the summation of their individual probabilities. In terms of some mathematical symbols, we write probability A union B is equal to probability A plus probability B. And note this, this is true for only mutually exclusive events. Now the question is that once we understand these axioms, how do we actually assign such numerical values satisfying these axioms? So we have different approaches to probability. One is what is known as a priori or the classical approach. The second is what is known as the relative frequency approach. And the third is the concept of subjective probability. Now, in the classical or a priori approach, essentially, without conducting a random experiment, sometimes it is possible to sort of, spell out the possible outcomes. And we also can think of conducting this experiment under certain postulated conditions. For example, often we talk about rolling a balanced die or throwing an unbiased coin. Now, under such conditions of unbiasedness, by unbiasedness we mean that we have no reason to expect one event in preference to another event to occur. So there, without even sort of conducting the experiment beforehand, we can assign probabilities to certain events. For example, in the tossing of a unbiased coin, we can always say that the probability of a head is half, and similarly the probability of a tail is also half. So in such kind of a situation, if we want to define probability of an event, say A, then the probability of this event can be defined as the ratio of the number of outcomes that favors a particular event to the total number of possible outcomes. Now here, underlying this particular definition of probability, we have certain assumptions. The assumptions are: 1, the events are to be mutually exclusive. Number 2, we should have a set of exhaustive number of events. And the third is the events should be sort of, independent of each other. So this is about the classical definition, but sometimes the conditions of the classical definition of probability cannot be met. And there we don't have any other way out but to actually conduct the experiment. And here what we consider is that we take the probability of a particular event, say A, as the relative frequency of the occurrence of that particular event in a large number of trials that might constitute the random experiment that is under consideration. So this is the relative frequency approach to probability. And finally, we have the subjective approach to the probability. Here, sometimes neither, the experiment can be conducted under postulated conditions, nor, we can have sort of such kind of a possibility of thinking of an experiment. There actually it is the subjective belief of the investigator that determines the probability of a particular event. For example, I might say the possibility of rain tomorrow is, say, 50%, or the possibility of sort of, the GDP of an economy being more than, say, 8% is 40%, or so on, or so forth. So this is the concept of subjective probability. Now, it doesn't mean that subjective probability has no role to play in sort of, real world situations, particularly in the field of social sciences, including economics. It is the concept of subjective probability is a very powerful concept, and based upon this concept of subjective probability, we can reach very important conclusions. So these are certain things about the concept of probability and how probability can be actually measured. Now comes certain theorems concerning probability. Now the purpose of these theorems is that with the help of these theorems we can sort of, assign probabilities to certain more complex events from the probabilities of simpler events. Now, one such sort of, theorem is what is known as the theorem of total probability, or the addition theorem of probability. If I can use the blackboard, I can write down the expression for the addition theorem of probability, or the theorem for the total probability. Supposing there are two mutually exclusive events. One is A, another is B. Then we can say that the probability of the occurrence of A or B is the probability A union B. And this probability is in fact the summation of the individual probabilities of these two events. So I can write this as PA plus PB. Now this is about two mutually exclusive events. But the two events need not be mutually exclusive. Then this theorem gets slightly modified. There the statement is in fact that the probability of either A or B or both. So in that case, if I write probability of A union B, then it will be, the expression will be slightly changed. And in that case, it will be probability of A plus probability of B minus probability of A intersection B. Now what is this event means? This is the event of both A and B. Alright. So in order to find out the probability of the occurrence of either A or B or both when the two events are not mutually exclusive, we need to know how to find the probability of A and B. Now the theorem that concerns with finding the probability of A intersection B or A and B is what is known as the compound theorem of probability or the multiplication theorem of probability. But before I discuss the multiplication theorem of probability, I need to explain the meaning of the conditional probability. Now Dr. Prakash has already given the concept of conditional event. Now, the conditional probability of an event, say B, conditional upon the occurrence of another event A, can be written in this particular form. Probability A given B, or rather let me correct it a little bit, probability of B given A. So this can be written as the product of, or rather the ratio of, probability A and B to the probability of A. Alright? Now from here we can define probability of A and B as the product of probability of A and probability of B given A. Alright? Similarly, we can write the probability of A given B as the ratio of probability of A and B divided by the probability of B. So again from there I can derive that probability of A and B in another way. Then it will be probability of B multiplied by probability of A given B. So these are the two equivalent expressions for the compound probability. So this is how we can find out the probability of a compound event like probability of A and B. Now the question, or what we have to bear in mind, that supposing that the two events are independent of each other, then it doesn't really mind whether it's the probability of B given A or simply the probability of B. And similarly, it doesn't really matter whether it's probability of A given B or simply the probability of B. Probability of A. I stand corrected here. So in that case, if the two events are independent of each other, then in such kind of a situation, probability of A intersection B is simply the product of their individual probabilities. Like this. Now, let me say some things about these two theorems. Now here, these two theorems I have talked about in connection with only two events. But these theorems are perfectly general in nature and they can be extended to any number of events. So these are certain things about the two theorems concerning probability, and one thing we must be sure about is that from these theorems we can sort of, we can obtain the probability of certain compound events, more complex events, from the probabilities, from our knowledge of the probabilities of simpler events. Alright? Now, once we have understood the concept of the conditional probability, then we can have a very important concept. We can introduce the concept of what is known as Bayes' theorem. Now this Bayes' theorem is very important in the sense that this provides us with a scope of modifying our prior belief about the occurrence of a particular event with the help of some objective data, and thereby we can arrive at certain important conclusions regarding decision making process. Now if I write down the statement for the Bayes' theorem, the statement
probability distributions, and we are all by now aware that in statistics, whenever we talk of probability distributions, when we talk of the parameters that are contained there, we basically concern ourselves with two aspects. One is the mean and the second is the variance. And this particular three results that we have now introduced can now be extended in probability theory to the concept of expectations, and from then on to the concept of variance. So within the limited time that we now have, could you please tell our viewers a little bit about the expectations, and that will be then helpful for us to wind up this brief session with the basic things that we have to know in the probability theory. Please.
Thank you, Dr. Prakash. Well, in order to introduce the concept of mathematical expectation and the variance in the context of probability, we need to introduce the concept of a probability distribution. Now, what is a probability distribution? A probability distribution is basically a statement regarding the possible values that a particular random variable may take with their associated probabilities. Now, supposing there is a random variable capital X and it takes certain values denoted by small x's like x1, x2, x3, etc., up to xn, n possible values. And supposing the associated probabilities of the random variable capital X taking a value equal to small x is P1. Similarly, it's taking a value small x2 is P2, and so on. And it's finally taking a value small xn is Pn. Then we can define the mathematical expectation of this random variable as the summation of the products of the values taken by the random variable and the associated probability. In other words, if I use the symbols, then it will be something like this. It will be, if I write the random variable as capital X and E stands for expectation. E stands, I'm sorry, I forgot to carry the mic. If E stands for capital X, then this is summation Pi Xi, where I varies from 1 to n. So X takes values like Xi's from 1 to n, and these are the associated probabilities. Now, the concept of mathematical expectation is very similar to the concept of arithmetic mean that we use in the context of an ordinary frequency distribution. So what there we do is that we try and find out an average, a weighted average of different values, the weights being equal to their respective frequencies. Here also we are doing the same thing. Here we are finding the weighted average of the different values that might be taken by a random variable, where the weights being their respective frequencies. Now, it is in this context we can also define the variance of a random variable. The variance of a random variable, as we know, can be defined as something like this. It can be written in terms of the probability notations as expectation of the random variable minus expectation of this, and then this is, we take the square of this. Now again, if we note that this concept is very similar to the concept of the variance as we use the term in the case of a frequency distribution. There what we do, there we sort of try and measure the squares, the average of the squares of the deviations of the individual values from their mean. Here also we are taking the average, because expectation is something like the concept of average from the different values of a particular random variable from the mean of that random variable, and then we square it. So the concept of variance is quite similar to the concept of variance as we use the term in, say, in the case of an ordinary frequency distribution. Now, in the case of an ordinary frequency distribution, the connotation that we attach to the concept of variance is that it measures how individual values are scattered around some central value. In the case of a random variable also, the connotation of variance is used in the same sense. So this is something about the variance of a random variable. So I think these are very important concepts in the sense that with the help of the concept of the expectation of a random variable, we have some kind of an idea about sort of, the most expected value that a random variable can take. And this particular concept has been used in so many contexts in the fields of natural science and in the fields of social sciences also. For example, in the game of lottery, this concept has been very much in use in the context of insurance. Taking an insurance, whether taking an insurance is worthwhile or not, we use this concept of the expectation. And of course, when we talk about later on theoretical distributions, and in the context of theoretical distributions, any theoretical distribution which we may see later, not in this session, that any theoretical distribution is totally defined in terms of these two parameters. Once we know these two parameters of any theoretical distribution, let it be our normal distribution, let it be our binomial distribution, let it be our Poisson distribution, the entire theoretical distribution is defined. And with the help of those theoretical distributions, we may reach important conclusions. So I think these are certain, state of importance of these two concepts. So Dr. Prakash.
Thank you very much. Thank you very much, Dr. Chatterjee, for having taken us through this session by explaining the various approaches to the probability, understanding of probability, the different axioms that are governed in understanding the concept of probability, the various events and the assumptions which are important, and some 3 or 4 basic results. And definitely we should be having another session focusing only on probability distributions, and this fundamental foundation that you have given in this course will be very useful for the students to understand. And as usual, we have not been able to have any questions from the viewers, and by that we can interpret that we have been able to explain the basic things so clearly as it is already explained in the print media, or it can be understood that questions will be there in further sessions that we will be taking up. And definitely I must say that in the short time that was available, though the course was entirely mathematical, it has still been possible for us to have a very clear idea about the basic things. For this I thank Dr. Chatterjee for having come here, and we hope that the session was very useful to the viewers. Thank you.
Thank you, Dr. Prakash.